Friends, good morning. Welcome to 127th episode of Tech Forum. We have two lectures per month, and today the first lecture of May will be on state of the art technology, LoRa network. LoRa is getting popular in the industrial automation very fast, and there are enormous applications of this wireless protocol. And definitely, we would like to introduce this technology to our Tech Forum members, and we can give some projects to college students based on that. Some industrial projects also can be seen. Today's speaker is Mr. Rahul Gaikwad. He will also share some of the projects he is handling in LoRa network. So friends, without spending much time, we have our Tech Forum member, Mr. Umesh Bhadkamkar. He will introduce to Rahul and his company. Over to you,
Yeah. Good morning,
Umesh ji.
everyone. I am Umesh Badkamkar. I would like to introduce you to my friend Rahul Gaikwad. He has done his BE Electronic from Pune University. He is a versatile and innovative person. He is an ex-engineer, Fox Solution, and right now he is having his own company, EG Logic, Ambad Nasik. He has experience in engineering, KUKA robotics, product development, industrial automation, SPM, mechanical design, electronic system, architecture design, firmware for the microcontroller, microprocessor, software, AI experience in various domains such as automobile, body shop automation, paint automation. We together design a text benches for Atlas Copco and many other company. Right now, the product on final prototype automation, electric vehicle, agriculture, variable frequency drive, BLDC drive, ultrasonic water flow meter on LoRa-based LoRa-based network, solar induction stove. Thank you. Now is over to the Mr. Rahul Gaikwad.
Okay, thank you, Umesh ji, for this nice introduction about Rahul. And I will request Mr. Rahul Gaikwad to start his presentation. Over to you, Rahul.
Hello, everybody. Today here we have gathered for the presentation of LoRaWAN network. LoRaWAN means long range radio. This is a complete technical and applications based presentation which we have made. First topic is introduction to IoT and LPWAN. LPWAN is low power wide area networks. The IoT landscape and why low power WAN networks matters in today's world. Then the second topic is what is LoRa and LoRaWAN? What is the difference between LoRa and LoRaWAN? Technical fundamentals and the protocol stack, how it has been implemented. Our third topic will be LoRaWAN architecture, how the architecture of a LoRa system has been designed. That is the end devices, gateways, networks, and application servers, which are based on the LoRaWAN technology. That is the full framework of the LoRaWAN technology. Then technical deep dive. We'll take a technical deep dive into the. This is too much of technical in-depth analysis of how the modulation happens, how the frequencies are being selected, what is spreading factor in LoRa, and what are the different types of classes in LoRaWAN technology. Now, since this protocol is wireless, so it has to have some encryption while being transmitted, so it cannot be intercepted by any other intercepting devices on the same frequency. So the fifth topic will be what is the security and the reliability of this, right? Then the implementation guide. If a LoRaWAN technology needs to be deployed on certain platform, then how it will be deployed. So first are the hardware things which will go, then how it has been software wise, how it will be configured, and what are the deployment steps for implementation of the full framework or the architecture. Seventh topic will be application and use cases where this technology can be used and already where it is being used in India or worldwide. Eighth topic is comparison and the future. What is the future versus alternatives, and what is the roadmap for the LoRaWAN technology throughout the world, or the steps which we are following at EG Logic for the roadmap of LoRaWAN technology. Yeah. So as of 2025, there were more than 75 billion devices which were connected to the LoRaWAN technology in one sense or the other, either private networks or LoRaWAN networks. We'll come to in the future. In the next slide, we'll come to know what is the difference between LoRa and LoRaWAN. But in total, there are 75 billion plus devices which are connected to this network. Presently, in 2026, the figures have increased. The IoT challenge. Now, what happens in this thing is everybody wants Internet of Things, all the devices to be connected, and the information should be collected through gateways or certain uh, devices who are at the center, which will connect the nodes data and relay it to the servers. So this challenge was there earlier, and people have been using different devices like Zigbee or NB IoT or some other wireless technologies which were not that successful for certain purposes or many of the purposes. Then came the LoRaWAN technology, which has been a successful thing at all the places. So what is the IoT challenge? Traditional Wi-Fi and Bluetooth, short range and high power. Now cellular, 4G or 5G. If we are going for cellular 4G or 5G, it is long range, but expensive, very expensive to implement. And they are very power hungry. Like the batteries for cellular networks will last maximum for maybe, if we are implementing for sensors or some data gathering, should not last more than a week or something like that. IoT devices need long range plus low power plus low cost. Now here also there is a difference. Cellular devices, the cost will be at a very higher pace, whereas in LoRaWAN the costs are presently minimalistic. We'll go to the next slide. Now, what is LoRa and LoRaWAN? So LoRa is the physical layer and LoRaWAN is the MAC layered protocol. So LoRa is the normal radio in which you can configure the nodes. Privately, you can have your own gateway. Privately, you can have your own server, and all these things connected together. You can have your own personalized protocol for that, which will be again redundant and encrypted. So it cannot be trapped. It cannot be intercepted. But then it becomes a private network. But at the places where at the scenarios or for applications like smart cities or bigger applications, what usually happens is like there are some LoRaWAN service providers, and like Tata is one of the LoRaWAN service providers. So the end devices or the end nodes, are those devices which actually gather data from the field, or vice versa. The data from the server or the input outputs can from the server through the gateway can be relayed to the end device, end node. So that is called the node. So there can be many different manufacturers of LoRaWAN nodes, and there is a standard registration procedure for that. Whereas in only LoRa, we can have our own procedure. Whereas in LoRaWAN, there is a standard documented procedure through which we can register the nodes or get connected to the LoRaWAN network and take their services. Fine. So in details, we'll go step by step. proprietary spread spectrum modulation. So it is a proprietary spread spectrum modulation. Spread spectrum is the spreading factor, which we will come to know about what is spectrum. So we'll come to know in the next slides. Whereas LoRaWAN, it is an open standard by LoRa Alliance, and they have set some procedures for the spreading factors, for some power dissipations or the transmission bandwidth and everything. And the modulation frequencies, at what frequencies it can be modulated, right? So this is the first point. Second point is developed by CYC Cycleo, acquired by Samtech, is one of the LoRa standard LoRa technology is being developed. It is a proprietary technology of Samtech from 2012 till now. So everybody using LoRa is using the Samtech developed stack of the LoRa network. So Samtech is licensing to all the different chip manufacturers. The main owner, like for ARM processor, the ARM Foundation is the owner. Same for LoRa LoRa Technology. Samtech is the owner of that technology. This in LoRaWAN defines the network protocol above LoRa. So any which ways in LoRaWAN, the Samtech hardware LoRa and the framework is to be acquired from the chip manufacturers who are using Samtech LoRa technology. And above that, this network protocol LoRa stack can be implemented. That is the software part. But the core part, the raw part, is LoRa, and that is given only by Samtech. Now this is Chirp Spread Spectrum technology. So this CSS technology also will come to know in the next slides. Manages communication between devices and network. So now here in all the points you'll come to know that the physical layer or the lower layer is always LoRa, which is by Samtech, and the LoRaWAN is the above layer in which all the communication, wireless communication protocols or the internet communication protocols have been implemented. Protocols similar to TCP/IP or HTTP post commands or HTTPS secure protocol, post commands and get commands. This operates in ISM bands, sub gigahertz. So same thing over here, handles authentication, security and data rates. Physical layer, it is like the LoRa band varies from countries to countries from 400 megahertz to 915 megahertz. So this is the physical layer, basically, the actual radio transmission which is happening. And LoRaWAN technology handles the authentication, security, because it has got the MAC layered protocol stack implemented in LoRaWAN. LoRa stack protocol, this LoRa physical layer protocol is being designed such that it has got exceptional range, and it has got a very strong interference immunity. Reason is, again, we'll come to know in the next slides how the spread spectrum technology works. And now in LoRa physical layer, what happens is you can implement whatever type of network you want to use. It can be a star of stars, or it can be a mesh network, or it can be wake up on mesh or L star network or a hybrid network. Whereas in LoRaWAN topology, it is always a star of star. So star network is like the node will always communicate with the gateway or the routing device or the routing device, we can call it. And the routing device always communicates with the server. So it is a star technology. Whereas in mesh, the devices also amongst themselves, they can communicate, which we can implement in the physical layer. That is the LoRa thing. And okay, fine. We'll go to the next point. Handles ranges up to 15 kilometers rural and 5 kilometer urban. Now, since this is a physical layer, understand it from the hardware point of view. Since if we are only implementing LoRa and we are not implementing the LoRaWAN stack, so whatever developed LoRaWAN stack is there, or the hardware framework which is being implemented by telecom operators like Tata, which is already supporting LoRaWAN, so we can go to any number of devices and at whatever ranges, because after 15 kilometers in rural or 5 kilometers in urban, it has been handled by the LoRaWAN gateways or the servers. So here in LoRaWAN, if we are using a ready-made LoRaWAN network, we can build our own LoRaWAN also. So we'll go to the next slide.
What do you mean by physical layer?
Physical layer means, see, LoRa is different, LoRaWAN is different. Now, how it is different, I'll tell you. LoRa is just the hardware layer of that full wireless communication technology. And whereas in LoRaWAN, it is a standard protocol which is already designed. We have to go through that technology, work through that protocol itself. We cannot take different steps to implement it. Now, how the LoRaWAN framework is there? 1 minute. Okay. So there are N devices. N devices has a LoRaWAN node on it. It can be connected to the sensors. It can be connected to actuators. It can be connected to relays if you want to remotely switch on applications like street light or fire alarms or something like that, whatever, like some scenarios which are coming into my mind. And then these are the devices which are the devices installed or implemented on the field itself. So whatever final device is there, this is the LoRaWAN device. And they are differentiated into class A, B, and C, which we'll come to know in the future, further slides. And these devices are generally battery powered. At the most of the times they are battery powered because LoRa technology was developed for ultra low power consumption. The life of batteries in LoRaWAN technologies varies from 5 years to 15 years or 16 years, or if the communication is very data transfer frequency is very low, then the battery power can go to 25-30 years also. Battery life of a single lithium ion 3.7 volt cell. So that is for that battery I'm talking about. Then there are LoRaWAN gateways, which is a IP protocol bridge for multi-channel. What happened now? Multi-channel is different. This is a LoRaWAN gateway, and the gateway is multi-channel. Generally, what happens is, like for India, the LoRa band, the LoRa frequencies which the government has allotted is from 865 megahertz to 867 megahertz. The bandwidth of this we can select any frequency with a bandwidth factor of say 75 kilohertz or 100 kilohertz. That will be the bandwidth between different frequencies. So, for example, if I select 100 devices of 865 megahertz band, then other 100 devices in the same locality communicating at the same time, I can select a different band for them of 865.1 megahertz. Similarly, I can have extra 100. Now, 100 is a very small number. The number of devices will be very much more. But why I'm saying 100 is just for an example point of view. So different frequencies the devices will be communicating so that congestion won't happen in the network. And now this end devices are not multi-channel. If they are transmitting at for example 865 megahertz, they'll receive also at 865 megahertz. So their frequency cannot be changed. And whereas in LoRaWAN gateways, the gateway hardware point of view, the gateway controller, the gateway architecture, and the radio frequency framework is totally different. So the gateways can handle multiple channels at a single time. And there is no, congestion, there is no data loss, nothing happens in that. Now the LoRaWAN gateway has got internet connectivity protocol like 4G or 5G modems, in which a SIM card will be there, or direct internet connectivity is there through fiber optic or whatever service provider. And then this information which is collected can be ported or is ported to the network server. So the network server collects all the data, and then the network server data is been passed forward to the application server. Application server will collect all the data. Where, for example, if some temperature monitoring or some data collection is there, then the application server will have the basic business logic for that. Or if a metering application is there, like we are developing ultrasonic water flow meters also. Our prototypes are almost completed. So the government is planning to change all the water meters throughout India. The mechanical meters will be discarded, and this ultrasonic water flow meters will be placed, which will have a battery life of 15 years. So there is no need to go and take meter reading. For MSCB also, for electric board also, there is no need to go and check the meter reading. Automatically, whenever the end device is being commissioned, we can program the end device to send data to the LoRa gateway once a day, twice a day, once a week, 4 times a week. So that time scheduling can be done on the data transmission of the information to the LoRa gateway. Time scheduling can be programmed in the LoRa nodes. Nodes are the end devices. So this data will go to the LoRa gateways. From the gateways, the information goes to the server. Server handles the data and gives it to the application server. Here, why I took the example of water meters is like billing information has to be done. So the business logic and data storage. Business logic is what? Generate bills for all the water meters data being collected and then deploy it. So that is the business logic. So this is one scenario. Another scenario, if we go, is like street lighting. So I want during the summer, the dawn and the dusk timings are very, they are different. During the winters, they are different. So some sensors will be there, or some time scheduling will be there on the application server. And the data from the application server will go to the network server to LoRa gateways, and the LoRa gateways will send the data to the end device when and how to switch on the street lights, or what would be the consumption, what is the electric consumption, or if there are some faults on the electric poles or for that light. So that data can be vice versa returned to the application server, and the business logic or the application logic can be written on the application server. Now, what is an end device? End device is, it can be a sensor, it can be actuators, trackers, communicate only uplink or downlink, and battery life of 10+ years. So I told you how the battery life varies. It will be on the frequency at or the interval at how many times we communicate. Gateway. What is the gateway? The gateway is a bridge. It is a LoRa and the Internet Protocol bridge. Multiple gateways receive same packets, diversity, no decryption. Multiple data can receive the same packet also, but there won't be any congestion or decryption, because the architecture framework and the at the basic level, the software is being written in such a fashion that the data will be redundant, but if the redundant data is being received twice, then it will be discarded. The network server deduplicates packets, selects best gateway, and handles MAC commands and ADR, everything. That is the network server. And the application server decrypts the payload which has been received from the network server, runs business logic, and pushes it to the dashboard, APIs, or whatever it is. Vice versa, the data can be, or the logic can be implemented at the application server, and then the data can be pushed to the end device through the LoRaWAN communication architecture. This is the architecture: end device, gateway, network server, and the app server. Now, technically diving deeper. In LoRaWAN, there is something called as a spreading factor. So what happens is each and every packet which has been transmitted from the node to the gateway or from the gateway to the node is been that same packet is been spread into a band at that same frequency with a shifting of, see now here, if the spreading factor is 7, so at 7 small different frequencies, of the selected frequency. For example, 865 megahertz is the selected frequency. Then at 865.05, one spreading factor will generate. 165.0 say 7, another spreading factor will generate. So what happens is the same data is being spread and transmitted at different frequencies, a small shift of frequencies. This packet has been transmitted, and at the collection point will be the LoRaWAN gateway. So it will receive this small spreaded data from different places, and it will reconstruct that data. So that is why what happens is because of this, the data loss is 0. I think so. You should, if you have any questions on this, you can ask me. So, for example, like if I need to pass an information in a crowd from one person, in a crowd of 1,000 people, from one person standing at one end of the crowd to another person who is standing at the other end of the crowd, through just one person, then there can be information loss, because while walking he can rethink and he would not translate the same sentence as it is to the person B person. The A person cannot transfer the same transcript or transfer the same sentence in the same way to the B person. So what happens, this information will be given to the 7 different people now, and it will have some there are CRC checks, everything is there in this protocol stack. So cyclic redundancy check and other things are there in this protocol stack. So whatever information, any which ways, it does not get lost in the packet. But since it is a radio packet,
But this will affect the speed, no?
Yeah, exactly. I'm coming to that point. So if we select a higher spreading factor, so LoRaWAN speeds are very low. LoRaWAN speeds are not very fast. So you cannot transfer video information on LoRa. It is not possible. LoRaWAN information is only for sensor-based automation, or automatic meter reading, or street lighting, or smart city small packet transmissions. Not for full 4K video transmission. It is not for that.
Okay.
And since it is for since the battery life also has to be extended to that many hours, that much time. So important. That is the reason why LoRa is being used in those scenarios, or machine-to-machine communication for small packet data, not very big packet data. Now here you can see, if the spreading factor is as the spreading factor increases, your data rate drops, right? You cannot have a huge amount. So for spreading factor 7, it has got spreading factor 1 to spreading factor 12. But the example over here, which is given, is only for the spreading factor 7, 9, and 12, just for example. So this example range is 2 kilometers. Data rate will be higher. Battery life will be best, because then it does not need to give the same. It does not need to make different packets at small different frequency intervals and then transmit it. So, but obvious that for spreading factor 7, the battery life will be good, and for spreading factor 12, the battery life will be less, but the penetration will be higher. So I hope you understand what I'm trying to say now.
Also, if the parameter that you are sending is changing fast.
So here the intervals should be like 1 second. See, for fast changing parameters like 1 second or 5 second changing, very far. That is what maximum what I have transmitted physically at actual my projects level. So maximum 200 milliseconds data refresh rate is there, which I have observed.
So if
you cannot implement it for like very high rapid data implementation.
Okay.
Here the scenario is different. Smart cities and control of very big actual data or metering data, that kind of data, LoRaWAN technology is there
Okay,
into.
okay. Like say
Not for
temperature
verif.
gradient is there and you are monitoring the rapid change in
Yeah,
temperature. Then
if you're monitoring, see, for example, if you are monitoring the temperature of a city, so every
then it
5
is okay.
minutes you can send that, that won't make a very big difference, right
Yeah,
now.
yeah, yeah. Okay, okay.
But if you are monitoring the temperature of a rapid changing furnace,
Yes.
then technology will work for a refresh rate of 100 milliseconds. But then
Uh,
transmitting at at an interval of 100 milliseconds will reduce your battery life drastically. Within a week, the battery will die out.
okay, okay.
So in those scenarios, the range, you will get the range, but in those scenarios, then uh, battery powered devices are not used, like solar powered or mains powered devices are hybrid power. Yani dual two three types of powers are being given. Battery will
Okay,
also be there. A charger will also be there. That kind of architecture has to be designed. But that
okay.
also,
Thank
I'm
you.
saying it only for 100 milliseconds. 1 millisecond
Wow.
data, it is tough to transfer. You can collect
Okay,
that data in a packet and then transfer that packet,
okay.
but not
Thank you.
instantaneous. Yes.
Thank
Okay,
you.
fine. Yeah. Sorry. So now every
Sorry,
country has
two
been,
questions on just now what you
yeah,
said. One
yeah.
is there any, if you collect the data in packet, will there any be
Okay.
limitation in terms of the packet size? For example, like application
Maximum
of
256
electric meter.
bytes packets I have transmitted.
Okay. And you also said that MACB meters, electric meters,
See,
like
the packet
MACB.
size is very small.
Yeah. No, no. One is for the meter reading usage, but Electric Board also claims that they can monitor the usage throughout and also give you your pattern, say for 3 months, how much is your charging pattern and all other
Yes,
thing.
yes,
So in such case also
yes.
they use this LoRaWAN network or there is
Yes,
some
yes.
other
In fact,
technology.
Adani has started using LoRaWAN network in his on his grid.
Okay, thanks.
Hmm.
My name is Amol Deshpande and I stay in Chinchwad, work in Tata Motors.
Oh, great.
Okay, great. So
Really
for
need.
like, if you give this kind of information, then I can say machine data, failure data, or hydraulics data, pneumatic data, process line data can be collected.
Hello. May I ask you a
Yes.
question, sir?
Yes.
I'm Sushil Samvat, sir, from Chhatrapati Sambhajinagar. I've
Yes,
got one
sir.
application where, like drone, where drone control is one link and video transmission from the picture is another.
Drone control will happen on LoRaWAN. Video transmission won't happen on LoRaWAN.
Okay. Is there any solution combining these two, or we have to have two
We can
different?
combine normal radio, normal RF, ham radio. We can combine. Ham
Okay.
radio has got higher data transfer rates.
Then this LoRaWAN, how good is it for uh, spoofing jamming?
Spoofing jamming, I didn't get you.
Like if a drone is going to be jammed by spoofing, okay. So how much susceptible is this?
Good. It is not possible to jam. Even if it is possible, even if somebody goes in on that frequency. Now
Okay.
you know how jamming works. Now how jamming works is if your
Y-
selected frequencies,
Yeah, yeah,
your
yeah.
this is an architecture. What question you have asked, no, sir? It is a good question, but this is a question from architecture point of view. So it should not transfer if it is a critical military based or defense based application. It should not transmit only on one frequency, that is 865 megahertz. It should keep on switching the frequency,
Right. Frequency hopping.
so that jamming is not possible in that thing.
Okay, sir. Okay, sir.
So now the different frequencies which have been allotted for in different areas is given over here, frequency bands by region. So I think so you can read it. Europe has got it 868 megahertz, 8 channels are there. North America has got 915 megahertz, 64 plus 8 channels are there. India, I don't know, they have given very less channels, 865 megahertz, 3 plus channels are there. And our LoRa band, our LoRa communication radio frequency is from 865 megahertz to 867 megahertz. You can check it on the internet also. You can Google it. So for India, it has got only 2 megahertz bandwidth for LoRa communication. And China has utilized the maximum number of channels, 470 megahertz. So now there are some, actually, while implementing, there are some challenges which we have overcome, but at the end of the session, we'll talk about it. Classes of device. So device classes. So there are class A device, class B device, class C device. As we had talked earlier also, uplink anytime to short downlink windows after transmit lowest power consumption. So what happens is that the frequency of uplink is very late, and it is not very fast, and interval I'm saying, and transmit at the lowest power, which is the default power. That is, you can program this LoRaWAN nodes to transmit from 5 milliwatt to 20 milliwatts. The 20 milliwatts is the highest power of that radio for transmission, which has been allotted and regularized by the government also. In class B, periodic downlink shorts beacons, moderate power, used for actuators like on-off karna hai kuch to bhi. So class C, continuous receive, immediate downlink, high power mains powered. So that's what I was talking. If you continuously want the data, then it cannot be a battery powered device, because the battery will drain out very fast. So it will be either 100% on mains powered, or you can have it, if mains failure occurs, then you can have it hybrid power also. So a battery will be also there, a solar panel will be there, and mains will also be there. So I'll go to the next slide. Now, security and reliability, activation methods. Over the air activation is there. So the framework, the stack has been designed such that like our cell phones, like you put a SIM card and then you get a message from the operator that, okay, we are registering the SIM, and then you have to put two, three parameters, your Aadhaar card details, XYZ details, and then automatically it has been activated. And some part of the information is provided by the SIM card manufacturer or the telecom operator itself. Similar over here, the device sends joint request to the app EUI or the development EUI or the development nouns. Then the network server responds to join accept. Now, okay. After that, session keys like the network keys, NWKS key or AppS key, are dynamically derived and more secure. This way it is more secure, recommended for production deployments. So this is the OTA, that is over the air activation method, is the more suited for, like for smart cities or like vehicle identification tags, whatever you want. So you'll just activate it over the air wherever the LoRa network is available. LoRa network, I mean to say, the LoRa gateway is available, it will get connected. But then it has to be activated. So there will be some authentication procedure for that. Then activation by personnel. The session key is pre-programmed into the devices. I can have the device serial number, which are pre-programmed and which will be unique according to my framework. If I want to deploy it privately, in, say, for example, at Tata Motors, so I don't need to use the generic stacks which are available, and I don't need to go through that activation method. I can devise my own method. I can have my own identification codes, and I can like, it is session keys which are pre-programmed in the devices, so I can have my own serial number. So no joint procedure is needed. Immediate communication is there because I know the devices. I can register from TAMO, like TAMO Tata Motors. I can have an authentication packet like TAMO 00 #B123, TAMO 00 #B124, 125, 126, like that. So, and I can tell my server that these will be my, so from 000 to 999 is my stack, and you can immediately get it, you immediately connect those. Okay. Simpler but less secure static keys, and used in LoRa power constrained environments. Constrained environments already I had talked. Encryption layer is there, so you cannot decrypt it without a key. And for every encrypted packet, there is a different key. So it cannot be, once you know the cipher or the key of one packet, you cannot decrypt another packet by using it. So it is very secure. AES 128. AES 120 is the same thing which is there in our Wi-Fi networks and all. Frame counter is there. Okay, fine. So end node module Samtec 1276, Samtec 1278, which is the actual Samtec is the holder of the LoRa stack. Then TTGO, LoRa 32, ESP, LoRa, STM32, many nodes are. We also have our own nodes. So gateway hardware is the rack 7248 Raspberry Pi gateway is there. Or different gateways are available. Network servers is the things to speak or the things network, which is free. Open source is the Chirp stack or the AWS IoT core for LoRaWAN, or we can have our own server also. So this now, any LoRa network has to be architectured to fit the application or what deployment we need to do. So all these steps are given over here. LoRaWAN applications in smart cities, smart street lighting, parking space, waste bin fill tracking, air quality and pollution sensors, water meter remote reading, which we are manufacturing. That's for agriculture, same thing, soil moisture, temperature, livestock. In farm, poultry farms, they can be livestock monitoring, or in buffalo farms or cow farms, weather stations, networks, irrigation automation, greenhouse environment control. Industry is also machine health monitoring, predictive maintenance alerts, energy consumption tracking, asset tracking in facilities, environment compliance logging. Logistics also same thing, internal logistics or long range or logistics like cold chain temperature monitoring, fleet and container tracking, and long mile delivery tracking, everything. Now, utility and energy like smart metering and energy, electricity metering, gas and oil, grid fault detection and all. It can be implemented there. Healthcare, same thing, but patient location tracking and medical asset management and all these things. Even the bed and the thing monitoring will be there. Now feature, LoRaWAN has got a 15 from the node to the gateway. The range is 15 kilometers in the urban areas, maximum. Sigfox is around 50 kilometers, but it is very power hungry and other problems are there. Then NB-IoT also some problems are there. And Zigbee network is only 100 meters. Like now Zigbee nobody is using. Data rate is very small, 0.3 kbps, 0.3 bytes per second to, 0.3 kilobytes per second to 50 kilobytes per second. Sigfox is 100 bytes per second. Here data packet problem is there with Sigfox. And NB-IoT is greater than 250 kilobytes per second, but then the battery cost is medium and then it is a cellular based network. Zigbee is a mesh, but the range is low, only 100 meters. So all the comparison chart has been given over here. I'll move on to the next slide. So key takeaways from this, what we have talked on this presentation are up to 15 kilometers in open areas, ideal for wide area deployments, like for rural areas, like if you go in a village, then we give 15 kilometers or more. If we are in the city, then the range might vary into from 2 kilometers, 1 kilometer, or it can go to 5 to 10 kilometers. I have got in areas I have tested in Nasik in certain areas where at certain places I got 5 to 7 kilometers of range. And in very congested areas, I got around 1.5 to 2 kilometers of range. Ultra low power. So battery life can be like, battery life depends on the packets which we are sending and the interval which we are sending. So 10 plus, it can go to many years. Secure by device like AES 128 dual layer encryption protection for every payload, every packet. Open and scalable. It is open source, open standard, supports millions of devices per network. So there is no limitation of how many devices can be connected to a single network. Low cost, very low cost. Free public TNN, reduced TCO. Versatile, it is a versatile thing. So you can implement it for smart cities, agriculture, industries, logistics, healthcare, and any applications, machines, factories, big factories, any application it can be implemented. real world scenarios. So for smart cities, some scenario has been given over here and implemented. What were the results? So energy was saved by 60%. Parking traffic was reduced by 30% reduced. And then some devices, how many devices per this? Okay, fine, I forgot. So 10 plus years of sensor life is there and all. This is a scenario where it is a case study for real deployment, city of Amsterdam, Netherlands. This was a case study. Now, smart agriculture, also precision farming, you can soil moisture. Now, these are packets which are very small packets. What all applications we are going through now, these are not like very high data hungry packets, very small data packets. So here the factory automation one case study has been given over here, right? Logistics tool chain, logistics and fleet management and tracking, and one scenario case study has been given. Smart water flooding and water supply management, drainage management, leakage management, sewage management. This another scenario has been given over here. And it can be used for building automation also. Smart building, BMS, what we call building management system. So it can be used over there also. Healthcare also, healthcare another application is there. So in Amsterdam itself, Amsterdam, Singapore, and Barcelona, it's only within these three countries. As for 2025, and still LoRa is a new technology, but still 5 million devices are being already deployed. Agriculture, USA, Australia, India, 1 million devices are already being used for sensors. Industry 4.0 automation, it can be like, yes, IoT, Industry 4.0, it can be used over there. Water utilities in 120 municipalities, France, Netherlands, India, it's been using them. Healthcare, everywhere, logistics. Fine, sir. Last May, I ended very fast because my time was running out and I started a little bit slow.
Okay, Rahul, it was a wonderful overview of the LoRa technology. I hope it made it interesting to the people.